Good afternoon, gentlemen. So the plan today is I'm going to go over graphing with you, and then you will have a practice worksheet that's a quiz. I'll talk more about that at the end of the lecture. But I did want to let you know, so as you know, today or earlier this week, we had the quiz. Your first test is scheduled for Monday, Tuesday of 9:21 to 9:22. As of right now, my plan is that we're going to continue doing it a partial online. However, I'm going to see how the quiz went and decide if we should do an entire week of testing. And I will let you know by the end of this week or start of next week on what my plan is. I just want to see the success that we have with that. So your homework will be the graphing worksheet and then completing the gum lab that you will be doing in class with me. You're going to be able to understand graphing, and then you're also going to be able to make a scientific method lab report with the gum lab. And so the gum lab will be very heavy grade because it's going to be worth a lot of points. However, you will get that practice graphing, and you have a week to complete the gum lab from when you first took it. So if you have any questions with that, hopefully they get answered here. However, it is in your best interest to pay attention. So, scientific variables in graphing. I have this little comic that I added. I'm very proud of it. It says, I think we should give it another shot. We should break up and I can prove it. And it's our relationship and it's a decline. Maybe you're right. I knew data would convince you. No, I just think I can do better than someone who doesn't label her exes. So, graphing. First things first. Remember the scientific method, we talked about it. They're experimentation with reliable results. So there are different types of experiments that you can have. And in our class, we do a lot of controlled experiments where we're only changing one variable. So it's really easy to graph it because we're only graphing one thing. The variables that we deal with are the independent variable, which is what I do. It's the one thing we are changing. So think about it. You're independent. You're doing your own thing. So it's my one thing because it's independent and it's changing. My dependent is what we're measuring, and that is what changes based on your independent variable. And then my controlled variable is what we keep the same. So for example, is my independent variable, like in this little image I have, my independent variable, what I'm manipulating, what I'm doing is I'm changing the amount of water, or I could change the amount of fertilizer. So I'm changing the amount of something. My dependent variable is always going to be the height of the plant. So it's like my effect of changing that. So if I only fertilize a plant with a little bit of fertilizer, just like this, it's going to be short. But if I do a lot of fertilizer in a plant that's next to it, for example, then it's going to be long. My other variable that I have is a controlled variable, and that's what's kept the same. So in this case, I could say, oh, okay, I'm going to change the amount of water, but I'll have the same amount of sun. The plants are all going to be in the same location, and maybe they're going to have the same amount of fertilizer. So my controls are what I keep the same. So think about when we're in a lab, we might be measuring different things. So we did the gum lab, so we are measuring the amount of loss of mass in that. But my control is I'm going to use the same balance the entire time. So I'm not changing the balance. So I get very accurate results with that. So it's like my control right there. So let's practice. So I'll do number 1 with you, and then you'll do number 2 and number 3. So you'll pause it and you'll take your notes. So number 1 reads, how do the different chemicals and fertilizers affect the plant growth? So in this question, I need to find, okay, so what's different? My dead giveaway, let me pull out my highlighter. There it is how do different chemicals and fertilizers? So I'm trying to see, okay, here's my different chemicals and fertilizers. So I have different chemicals and different fertilizers. That is my independent. Beautiful. I want to see how it's affecting plant growth. So I can measure my plant growth based on the different chemicals. So let me change this to a pen because that might be easier. So my independent is I'm changing my different chemicals and I want to see the effect on plant growth. So that is my dependent. So now I want you to do experiment 2. It reads, how long does it take 3 different types of enzymes each individually digest a liter of milk? So pause this and write down your independent variable and your dependent variable. Cool. I'm assuming you're back. So, how long does it take 3 different types of enzymes each individually digest a liter of milk? So, I'm using different enzymes, different types of enzymes. That is my independent because it's different. I'm changing my enzyme, and I want to see how long does it take to digest a liter of milk. So, I'm measuring how long it takes to digest a liter of milk. So, right there, I have my independent and I have my dependent. Number 3, what is the effect of the density of different mediums on the speed at which light travels? Pause this, and I want you to identify the independent and the dependent variables. I bet you like just watching me wait for you, but I hope you're back now. So, what is the effective density? So, I want to know the effective density on different mediums on what light travels. So, the effective density, I want to measure the density of different mediums. So, my density is actually my dependent, and my different mediums of light, air, glass are my independent. The reason why is the speed of light is a constant value, and so I can measure what the speed changes at based on the medium, but I can't change the speed of light. And the speed of light won't be dependent on the different mediums. It's always going to travel at the same speed. It just might go through at a different, it might slow down based on how it's going. So think about it. If I'm in a classroom and I have all the lights on, it's going to travel really fast. But if I'm here and maybe I cover it, it's not going to travel as fast. Or if I put maybe the light in Jello, it's going to be a little bit harder. So I'm studying the density, and then I have my different mediums. Yep. All right, graphing basics. So your independent variable is always going to be your x-axis. Your dependent variable is always your y-axis, and your title is always your independent versus dependent. Now, when you start graphing, it's really difficult to really grasp it because sometimes you're like, oh, I can't remember what goes on the x-axis. I can't remember what goes on the y-axis. Just know this. If you think about it, your independent variable is your x-axis. You have a girlfriend and you break up because you're like, I don't got time for girls. I'm a young man. I got things to do like sports and video games. So you break up with her. She becomes your ex, but you become independent from her. So your x value is your independent because you broke up with her. So now you're independent. So they're the same. When you break up with a girl, you're independent. Your x is your independent. Your dependent variable is your y value. And just think about it, when you're dependent, you're with someone. So you are in a relationship. That's it. Your titles are always going to be x first, y. Good way to remember this is that your x becomes before your y in the alphabet. So your x is your independent. Your dependent's going to come after for your title. And you'll always, always, always do a best fit line, which is this straight line. I know that's not a straight line, but I go more in detail into it. So when you're doing your parts of your graph, which I have this little nice boy here, your x-axis and your y-axis have to increase at a constant value. They don't have to be the same. So for example, right here, I have my zeros here, and then my time is in minutes and it increases by 5s, whereas my temperature, we see it's increasing by 1. So your variables don't have to be same constant. So if my x is my 5, I don't have to have my y as my 5. However, I can't just hop around where I want. They have to increase consistently, and they have to increase. You cannot have a decrease. With all your graphs, your axes must be labeled with units at all times. You must have a title, and you must have a legend. A legend is if you're using multiple graphs on one, you have to show me what you're doing. So remember, units, units, units. No naked numbers. Not in my classroom. That is inappropriate. We love units. So make sure all of your legends have your information, and then your axes have your units and what they are. And it's going at a constant, and it's labeled correctly, and there's a title. When we graph, the reason we do it is we really want to identify general trends. The trends are always line graphs in chem. We don't do a pie graph. We don't do a bar graph. We don't do that. It's always, always, always a line graph, and we use our best fit line. It allows us to predict things, and we can extrapolate data from the graph. And then we can also look at a graph and say, hey, I know that this is an outlier, and so it's not accurate or true to my data because something happened here. So I can take that out and be like, I know that there was a mistake here. However, this is what my prediction should look like. Your general trends or relationships that you see are always a direct relationship where both of our values are increasing. So if it's direct, they're directly correlated. So it's like, think about it, when you're direct with someone, maybe you're on the same page, and so you're both increasing or maybe decreasing. So it looks like graph A, where I see X is increasing, Y is increasing, it's shooting up. And inverse is opposite. So where my X is increasing, my Y would be decreasing. So think about one value goes up, the other goes down. Direct, together, inverse, opposite. Flat line is where your independent is always going to increase. Like, see right here, my X has to increase, but my Y value is going to stay the same. It's not going to change. So I just have a flat line for that. So you're never going to have your X stay the same, because that would make no sense to see that. Like a line right here, you're not really measuring anything, because a lot of times, remember, X is changing. So we can't have the same value. So direct, together, inverse, opposite, flat line, Y is the same. Your best fit line, let me move myself, there we go, is your average representation of the data. You do not connect the dots, never, ever, ever, ever. It goes all the way up to the y-axis and all the way to the end of your graph. So for example, I have my graph right here. I start here and I end here. It's going to go the entire way because it's just an average representation of the data you collected. As you can see, I'm not dot to dot, because if I did dot to dot, it would not help me. It'd be confusing. So I use my straight line. It's where your slope comes in. Think about that. This also allows me to identify data points that are outside the best fit line. So for example, a lot of these are pretty close, but I have a data point right here. And so when I have that, I might say, oh, I saw an error in there. Maybe I had an instrument error. You can account for that and explain that data point away. But you can tell, like, hey, it's not with my general trend. I can identify, hey, this for real is an outlier. So an example graph that I want you to do is, I'm going to scoot myself over. I want you to create a graph, and then I need you to submit it to me on Canvas. So the purpose of the study was to see how the amount of study time affected the student's grade on a test. So I want you to A, identify your independent variable, and B, your dependent variable. And then I want to see an example graph on notability, and I just need you to email me that. Actually, post it to me on Canvas. I'll make a file upload for you. So do it on Canvas. Don't email me. So first off, I'm going to help you right here. So your X and your Y. But think about it. My study time is changing. My grade's dependent on the study time. So grab that and then submit it to me on Canvas. Okay, perfect. I was going to do a graphing activity. However, we're going to do this in class instead next time I see you. And that's all I have for you today. So your job is to submit this graph to me on Canvas. And then I also would like you to go, discard that, hold on. You will go to Canvas, and I have your graphing practice homework there for you. Let that load. It's a quiz. However, you have 5 attempts to complete it, and you'll go through the questions. So if I preview it, for example, it will go through each question for you. So here, question 1, you have to complete it to move on. You'll complete the graph, you'll upload the file, and then I have a series of questions you'll answer. You have 5 attempts to complete this. Not all the questions have a correct answer, because I do have to go view them myself. This is worth a grade. It's kind of like a lab grade if you think about it. But you do have 5 attempts, and if you have any questions, please let me know. However, it shouldn't be too bad. You will be uploading files, so you can use Notability to submit those, and I do not have a timestamp on this. And so while it's going to show you your time elapsed, it's not a finish this in 30 minutes kind of quiz. It's really take your time, work on it, and then that way you can go back through. I will have them graded hopefully by the end of the week. You have that week to finish it, so you have the weekend to fix any errors that you might have noticed. However, make sure you get this in as soon as possible. If you have any questions, email me, but make sure you complete that graphing example that I showed you, and I'll have somewhere on Canvas for you to upload it. I hope you have a wonderful day, and bye.